Lesson 14 is on the docket. We're going to dig a little deeper and a little further today. More with z-scores and the first part of two lessons about the ubiquitous central limit theorem. We are in the fall time of year and we have lots of pretty color around us. So between the pretty color and the scintillating mathematics, let's get started. As usual, I like to begin with a series of questions that are designed to dig a little deeper and get into z-scores a little bit more. Make sure we know what we're doing with those different levels, easy, medium, hard, and so on and so forth. So, we'll stop and start here. Go ahead. All right, so as usual, we give you the z-score formula. I would say that if we were taking a test in class, I would not give you that formula. I would expect you to know the formula. But given that we're not taking them in class and you are taking them at home, you definitely have a reference sheet available to you, or as I like to call it, a cheat sheet. So use the z-score formula to find the z-score of a score of 92 in a normal distribution when the mean is 100, the standard deviation is 10. So the z-score will be, keep in mind we put the score first minus the mean. So the score is 92, the mean is 100, over the standard deviation, which is 10. And that gives me negative 8/10, also known as negative 0.8. We do like to convert z-scores to decimals because that is how we read the table. Okay, so I would call that a pretty basic fundamental type of z-score question that you should all be able to nail every single time. Once again, there is the z-score formula. Now, where are we going with this? Use the z-score formula to find the z-score of a score of 92 in a normal distribution when the mean is 100 and the standard deviation is 10. Go ahead. Okay. Same formula, same everything. Sometimes you're actually better off not using the formula, though. For instance, what if we wanted a z-score of 110? 120, 130, 90, 80, 70. You see, when those things happen, what we're able to do is realize that they're all 100 with a series of 10s added to them. 110 is plus a 10. A 10 is a standard deviation. A standard deviation is called a z-score, so that would be up 1. So 110 would have a z-score of 1. 120 would be up 2 10s or have a z-score of 2. 130 would be up 3 10s or have a z-score of 3. 90 would be down 1 z-score and have a z-score of negative 1. 80 would be down 2 z-scores or a z-score of negative 2. And 70 would be down 3 or a z-score of negative 3. Okay? Once again, z-score means how many standard deviations are above or below the mean. For a mean of 100 and a standard deviation of 10, 110 is 100 plus 10. So it is one standard deviation, one set of 10 above the mean. So that z-score is 1. 120 is 2 10s above the mean, so that z-score is 2. 130 is 3 z-scores above the mean, so that z-score is 3. 90 is 1 below the mean, right? Because it's 110 below 100. So that's a z-score of negative 1. 80 is 2 10s below 100, so that's a z-score of negative 2. And 70 is 3 z-scores below 100, so that would be a z-score of negative 3. So if you understand what a z-score is, you can do whole standard deviations very, very, very quickly off the top of your head. What about a score of 115? Well, 115 is 1.5 z-scores, right? Because 10 is a z-score and 15 is a 10 plus a 5. So that's 1.5 z-scores. There you go. And then 75 would be 25 below 100. So that's down 2.5 z-scores. So the z-score is negative 2 1/2. So these ones with fractions or halves, they're not quite as easy, but I think you can learn to recognize them over time. Okay, a z-score that is 8 points above the mean corresponds to a z-score of 2. What is the standard deviation? Okay, so that 8 points above the mean is 2 a z-score of 2, which means it's 2 standard deviations above the mean. So 8 divided by 2 works out to be 4. So what we can say is the standard deviation is 4. You try the next one. Okay. A score of 12 points above the mean corresponds to a z-score of 1.5. What's the standard deviation? So basically, what number times 1.5, because the z-score is the number of standard deviations. So what number, the standard deviation answer, times 1.5, the z-score, is going to give me 12. We can use inverses on that and just do 12 divided by 1.5, and we get 8. And that makes sense, right? Because a whole 8 is 8, and half of 8 is 4. And 1.5 eighths is an 8 and a 4, which is 12. So that makes a perfect z-score of 1.5. Last one, a score that is 18 points below the mean corresponds to a z-score of -2. What's the standard deviation? Well, it's 18 points below the mean. A z-score of 2 means that you got to divide it by 2, and we get 9. Okay? Try this one. You're going to need your table for it, so make sure you're looking up with your table. And there's a table to look at in case you didn't do it. And when we work backwards trying to find percentiles, we want to find the percentile in the table. So if you're at the 75th percentile, what you are is 25% above the mid-range. See, the tables don't go up to a 1.000 or 100%. It'll go from 0 to 50%, and then you add the 50% for the left-hand half of the graph. So the closest you're going to get to 0.25 is 0.2587. And if you notice, that pairs up on the left with 0.6 and on the top with 0.07. So altogether, that gives you a z-score. Don't forget the 0.5 on the left that you have to add into this, of 0.74857. And that's going to equal x minus 90 over 12. And all you need to do at this point is cross multiply, okay? This is your z-score formula that you start with. The z-score is the x value we're talking about minus the mean over the standard deviation. We know in this case, because of the formula, the normal formula distribution, that the mean is 90 and the standard deviation is 12. So here's my mean of 90. Here's my standard deviation of 12. I'm looking for the score. And I know I underlined 0.24857, but please keep in mind, as I mentioned a couple of times, that this is the right-hand part of the graph area only. And we also have the left-hand part, which is included in the diagram, but not in the table. So we have to add that left-hand half, which is 0.5. And if I do 0.5 plus 0.24857, I get 0.74857. Cross multiplying, adding the 90, and I get 98.98284. So that's the score, 98 point, let's round it off, 98.98 to the 75th percentile. Okay? All right, so we're going to stop at this point, and we will begin the next video with this question.